Good morning, Year 8, and welcome to Wednesday, the 10th of June. Okay, we've been doing some work on sequences for the last few lessons. Last time round, a lot of you seem to be okay with the nth term work. We're going to find a rule in terms of n being it's the position of the number in a sequence. Quite a lot of you didn't show me an awful lot of work in between times, so I'll go back to my modelling. If I look at the example that I've got here, the sequence 5, 8, 11 and 14. I've asked the question, is 153 in this sequence? Well, in order to tell that, you could write all the numbers out till you get to 153, but A, that would take ages, and B, there's a chance that you'll make a mistake. Whereas B, what we should do is find the nth term. The numbers go up in threes, just at my 3 times table, so I know the rule is going to be 3n somewhere. 3 times 1, 3 times 2, 3 times 3, 3 times n. If I write out my 3 times table, 3, 6, 9, 12, to get my sequence, I see I've got to add 2 to it. So my sequence is 2 more than my 3 times table, so it's 3n plus 2. Now to find out if 153 is in the sequence, if I look at my sequence at the start, I've got 5 and 8 and 11. Those numbers are in the sequence, but obviously 6 and 7 and 9 and 10 aren't. So if I form an equation, 3n plus 2 equals 153, if n is a whole number answer, it's in my sequence. If n isn't a whole number answer, it's not. If I take 2 from both sides, I get 3n is 151. If I divide both sides by 3, I get the answer of 50. Remainder 1. Because there's a remainder, the number isn't in my sequence. You can't just say yes, you can't just say no, you've got to be able to prove it. And that's your job for today. Okay, have a go at this, and then once you've finished, please remember there's an exercise on Hegarty Math that needs completing. Thanks. See you on Friday.